Welcome back. Now that we understand the project requirements, let's look at the architecture for our solution. As we discussed, we'll ingest the COVID-19 data from the European Center for Disease Prevention and Control website, otherwise called ECDC. We use the HTTP connector within Azure Data Factory to get the data. For the Eurostat data, we'll keep the population file in an Azure storage account and ingest from there. We could get this data directly from the Eurostat website, but we'll instead ingest from an Azure storage account. This is only because I want to teach you another type of connector other than HTTP connector that we've already used for the COVID-19 data. Both datasets will be ingested into the Azure Data Lake storage. We'll then use Azure Data Factory to transform this data. We'll use the transformation capability called data flows within the Data Factory for the couple of datasets. We'll use HD Insight for another dataset and Azure Databricks for another one. For the HD Insight and the Databricks transformations, Data Factory will be used as the orchestration tool rather than the transformation tool. All of the transformed data will then be stored in our data lake for use in machine learning models. We won't be building the machine learning models as it's out scope for this course. We'll also push the subset of the required data to the SQL database so that it can be used for reporting. We'll then build a Power BI report from this data. The focus of this course is Azure Data Factory rather than Power BI. But I'll do a quick lesson on building the report. Let's now have a look at the solution to understand why we've used these specific technologies. Firstly, we've used Azure Data Factory for all our data integration and orchestration. We used ADF for data integration because it provides connectors to all our data sources in this project. And also it provides a vast array of connectors that could be used to expand the project in the future when a new requirement arises. Similarly, Data Factory has the connectors to orchestrate our workflow. For example, it can orchestrate the workflow with running transformations in HD Insight and Azure Databricks. Next, let's have a look at the transformation technologies being used. We've used 3 transformation technologies here: Data Flow within Data Factory, HD Insight, and Azure Databricks. I'm using all 3 just to show you the capabilities of Azure Data Factory. We can use any one of these to meet all our needs in this project, but I just wanted to show you and make you understand the differences so that you can use the right one in your projects. All 3 of these technologies are run on distributed infrastructure and they're easily scalable. The difference is that Data Flow gives you a code-free transformation tool which makes it easy to develop and maintain the transformation. But at the same time, it is good for simple and medium-level complexity transformations, but it lacks in its ability to develop complex transformations. The other 2 options, HD Insight and Databricks, will require you to write the code in one of Spark-supported languages such as Python, Scala, or Spark SQL. HD Insight also gives you the ability to write code in a SQL-like language called Hive and also a scripting language called Pig. So based on this, you should choose the tool of your choice depending on your requirement and the technical skill available within the team. Now let's have a look at the storage solutions used. We're using Azure Blob Storage to keep the population data, Azure Data Lake Storage Gen 2 as the data lake, Azure SQL Database for our data warehouse solution. Let's go through each one of these. Azure Blob Storage is a solution for storing large amount of text or binary data. You can use blob storage to distribute data centrally in a business or to expose to the world. In this case, let's assume that one of our teams have collected data from Eurostat about the country's population information, curated the data and made it available for other business areas. And we are one of the teams for which the data has been distributed via the blob storage. Next, we've used as Azure Data Lake Gen 2 for our data lake. Azure Data Lake Gen 2 is Azure's recommended storage solution for building enterprise-level data lakes. It can store multiple petabytes of data while sustaining hundreds of gigabytes of throughput. This is built on top of Azure Blob Storage, so it is cost-effective, but with it added benefits of better performance management and security. You can mount data lake storage to add the big data solutions such as Hadoop databases and Synapse Analytics. And finally, we've used Azure SQL Database for our data warehouse solution. Azure's Synapse Analytics, formerly called Azure Data Warehouse, is a better solution for large data warehouses due to its massively parallel processing architecture. We're using SQL Database instead, mainly due to the small amount of data we are processing. If you would like to use Synapse, please feel free to do so. Everything taught here should work except for connectors to the database, which you'll have to point at the Synapse connectors rather than the SQL database connections. We're using Power BI to report the trends we want to report. It has rich features that we can use to develop meaningful reports and share across our teams. Hope this has given you an understanding of our solution architecture. In the future session, I'll give you more insights into everything that we've discussed here. So that's the end of this session. And I'll see you in the next one.